Hello dear students. In previous session we learned about graph representations, different types of graphs and graph traversal algorithms like BFS and DFS. In this session we are going to study one of the most important graph algorithms called Dijkstra's algorithm. It is used for finding the shortest path. So what does it mean by shortest path? Let us first understand. Suppose you are traveling from your home to college. There may be different there may be three different routes. So route 1 has 15 kilometer, route 2 has 18 kilometer, route 3 has 20 kilometer. Which one would you choose? Obviously, you would choose the shortest route, provided the traffic conditions are similar. So that suppose information is spreading through a social network, if a company wants to send an advertisement from one user to another, it wants the message to reach as quickly as possible. This means finding the shortest communication path. So the Dijkstra's algorithm plays a major role in the finding of shortest paths. So this algorithm works on weighted graphs. So the Dijkstra's algorithm works on weighted graphs, but there is one important condition. All edge weights must be non-negative, and also in other words the weight should be 0 or positive. And also another one important condition is it starts from only one source node. So from this source it calculates the shortest distance to every other node. So the step-by-step procedure of the Dijkstra's algorithm is here. So the first step is initialization. So choose the source node, assign distance equal to 0 for the source node, distance equal to infinity for every other node, mark all nodes as unvisited. The source node becomes the current node. So in the next step, update neighbors distance. So look at all neighboring nodes of the current node. Then calculate the tentative distance. So the tentative distance equal to current distance plus edge weight. So if this tentative distance is smaller than the previously stored distance, then we will update it. And the next step is mark current node as visited. After checking all neighbors, mark the current node as visited. So the next step is select the next current node. So among all unvisited nodes, choose the one with the smallest tentative distance. This node becomes the new current node. So repeat the same process. So the last step is stop condition. So we have to continue the same process until the destination has been finalized or all nodes have been visited. At this point, the algorithm has found the shortest path. So now we'll see the simple execution steps of the Dijkstra's algorithm for the given graph. So let us take this example graph. So this is the step-by-step execution. So look at this graph. So here we have 5 nodes. S is the source node and T is the destination node. So S is the source node, T is the destination node. Remaining 3 nodes are intermediate nodes. So each node has a number right on it. These numbers are called edge weights. They may represent distance, time or cost. We want to find the shortest path from node S to T. So let's begin from the step 1. So the marked arrow is, this graph is the first initial graph. So since S is the starting point, the distance from S to itself is 0. So we write 0 inside the node S. For all other nodes, we don't know the distance yet. So therefore we assign infinitive. Okay. So it means top node is infinitive, bottom left node is infinitive, bottom middle node is infinitive and T is also infinitive. In the next step, we update the neighbors of S. So the first neighbor's distance is 12. So we replace infinitive with the 12. So in the next neighbor node is 4. So then we will replace it with 4. So now our known distances are top node is 12, bottom left node is 4. Since we have completely processed node yes, so we mark it as visited. So next select the smallest distance. Among all unvisited nodes, choose the node having the smallest distance. So obviously 4 is the smallest distance. So we move to the bottom left node 4. This becomes our current node. Next we will calculate the distances through this node. First, let's move to the top node. So the current distance to the bottom left is 4. The edge from the bottom left is 6. So 4 plus 6 is 10. So we update it with 10. So next, previously the top node has the distance 12. Now we found the shortest path 12. So we will replace it with 10. So now let's calculate the distance to the bottom middle node. Current distance is 4, edge weight is 2. So 4 plus 2 equal to 6. So there we update it to 6. So next, again choose the smallest distance. Top node equal to 10, bottom middle node equal to 6, destination is infinitive. Which one is smaller? 6. Therefore, the bottom middle node becomes the current node. So again we always choose the smallest available distance. Now the current distance is 6, edge weight is 4. So update 6 plus 2 equal to 8. Previously the top node has the distance 10. Now it is updated to 8. Now look at the destination node. The current distance is 6. So the edge weight is 12. So 6 plus 12 is 18. So update it to the 18. So mark the bottom middle node as visited. Next, visit the top node. So which is the smaller value 8. Now check whether we can reach the destination more efficiently. The distance to the top node is 8. The edge from the top node to T has weight 8. So 8 plus 8 is 16. Previously the destination has the weight of 18. So 16 is the smaller. So now the destination becomes 16. So mark the top node as visited. Next visit the destination. So now only the destination node remains. Its shortest distance has already been determined. So visit it. So that the shortest distance from the source S to T is 0, 4, 6, 8 and 16. So we trace the update backwards. The destination was updated through the top node. The top node was updated by the bottom middle node. The bottom middle node was updated by the bottom left node. So which is, so the destination is updated by the top node. This one is the top node. Top node is updated by the bottom middle node. So the bottom middle node is updated by the bottom left node. So therefore the shortest distance is S and then bottom left and then bottom middle and then top node. Next one is the destination node. So that the distances are 4 plus 2 plus and then 2 plus 8. So which one is the 16? So this is our target or shortest distance value. So it is very simple. Starts from the source node, assign a distance of 0 to source node and infinite to all other nodes. Visit the nearest visited node. Update the distance of its neighboring node if a shortest path is found. Then mark the node as visited. Repeat this process until all nodes have been visited or the destination has been reached. So the most important rule to remember is always choose the unvisited node with the smallest known distance. So this is for the execution of Dijkstra's algorithm. So the Dijkstra's algorithm is source dependent, finding the shortest path between the source to all other nodes to generate all pair shortest path. We can run Dijkstra's algorithm n time. or use other algorithms such as Floyd-Warshall algorithm. So if we want to compute the distance shortest path from source V to destination D, we can stop the algorithm once the shortest path to the destination node has been determined. So thank you students.